Hello and welcome. My name is Muhammad Fazrul bin Muhammadin. Today I will briefly explain about the precast reinforced concrete piles, also known as RC piles, and their role in construction. RC piles are important because they help transfer building loads down into harder soil layers like bedrock. They are made from high-strength concrete and reinforced steel, which make them strong enough to handle heavy pressure and bending, especially in soft or watery ground. There are several piling methods, but in this case we use the driving method. This involves hammering the pile into the ground until it reaches the right depth. This method is fast, has a high load capacity, and doesn't need digging since the piles go in vertically. However, it can also be noisy and might cause damage to underground utilities during the hammering process. For the Batu Kawa Recreational Park project in Kuching, this method is very suitable. It provides strong support and meets the needs of the anti-flood park.
Hi, my name is Valerie. So now I'm going to explain about the project background of our case study. So due to frequent flooding in Batu Kawa, the Sarawak government has allocated around 19.88 million to transform the Batu Kawa Recreational Park into anti-flood park. It is located at Jalan Batu Kawa, Kuching, and the project featured a sunken dry pond to collect and redirect excess rainwater to Sungai Maung Kanan to reduce the flood risk. The project is awarded to MS Wawasan Capital Limited, and the construction was begun on 24th of May 2024 and is expected to finish in May 2026. So during our site visit, we found that the park soil is clayey, meaning it retains water and drains slowly. To address this, precast reinforced concrete piles are used. The structural elements shaped into circle, rectangular or octagons to support heavy loads and stabilize foundations. It is produced off-site under controlled condition and they're delivered for installation on-site. So for this project, dry precast concrete piles were chosen for their high load bearing capacity and cost effectiveness. So further details of the piling method will be explained in the next section by Kaironisa.
Hi, my name is Kaironisa binti Nohardi. I will now explain about our case study. For this case study, we focus on the use of precast reinforced concrete piles at construction site located in Batu Kawa. These piles were selected because the soil condition at the site is weak and not strong enough to support heavy structural loads directly. By using precast RC piles, the weight of the structure can be transferred to a deeper and stronger soil layers or bedrock, which helps to avoid settlement and ensures the stability of the building.
So moving on from the previous topic, now I'm going to explain about the method of installation for the precast reinforced concrete piles. So the installation of precast reinforced concrete piles can be done by driving the ready-made piles into the ground, which it provides support to the earth structure by piling equipment. By using a piling rig, the piles are driven into the ground by drop hammers. It is done at authorized height that had been determined. That when the hammer is attached to the piling rig, it will be dropped to the pile head until set is reached. Set is the stage where the hard strata have been reached. So the following are the methods of installation for precast reinforced concrete piles. So the first step is setting out. The position of each pile is set out, and the temporary benchmark TBM is formed on site to determine the cut-off level of the piles. Second is piling rig preparation. The first is to make sure the position of the piling rig is vertical by using a spirit level or plumb. Third is marking pile line. Mark the pile shaft to help track how far it penetrates during driving and to provide a rough indication for estimating the pile set. Number 4 is preparation of pile head. It is important to protect the pile head or joint plate by installing a mild steel covering using packing or cushioning such as plywood between the head pile and the cushion head. Positioning pile. Lift the precast reinforcement concrete pile and place them at the determined position while checking on their vertical alignment regularly. Number 6 is driven pile driving operations. start by hammering process of the piling while monitoring the penetration into the ground by checking the markings on the pile. Number 7 is measurement offset. Hold the end of the pencil firmly against the timber board beside the piling without touching it, so the other end traces the pile's movement on graph paper fixed to the pile during 10 hammer blows. Number 8 is the stopping criteria. The piling work can be stopped once the displacement is lower than the proposed displacement, which is over 10 blows. The piling work can be continued if the displacement exceeds the proposed number. So last but not least, I'm going to explain about the 9th step, which is the pile lightening and joint welding. So the other end of the piles are connected using a coupling device to join the other ends of the other piles. This can be done through drilling and grouting or using a pile extension casing. The connected ends can be secured by doing welding work to the joint plate. So now I'm going to pass the slide to the next person.
Moving on to the advantages of precast reinforced concrete piles installed using the drive-in method. This method is widely used in construction, especially for structures that require strong support in foundation. So the first one is quick installation. Driven piles are installed directly into the ground using impact force, which means no excavation work is needed. This makes the site operation faster, more organized and efficient, especially helpful when working with tight schedules. Second is performs well in different soil types. Driven piles work well in many soil conditions, such as soft soil, clay, sand, and areas with high groundwater levels. During installation, the surrounding soils get compacted naturally, which increase both friction along the pile and support at the tips. This helps ensure long-term stability. And the third is high load bearing capacity. Driven piles offer strong support for heavy structures. The impact during installation strengthens the connection between the pile's surface and the soil, improving the overall bearing capacity. This makes them suitable for large building and underground drainage system. And 4. Suitable for low preparation sites. This method can be used even if the ground has not been fully leveled or prepared. The piles are simply driven into place, which minimize disturbance to the natural source and reduce the risk of ground instability. Now, let's take a look at disadvantage of precast reinforced concrete piles using the driven method. Although this technique is widely used due to its strength and soil adaptability, there are some limitations that need to be considered during construction planning. So the first one is noise and vibration interference. One major drawback is the high level of noise and vibration during piles installation. The impact from driven hammers can disturb nearby environments, especially around house, schools, or hospital. It may also affect the comfort of the surrounding community if mitigation measures are not taken. Second one is risk to underground utilities. Driven piles are installed directly into the ground without excavation. While efficient, this approach can risk damaging underground utilities like water pipes, power cables, and sewer lines. Unintentional impact may lead to costly emergency repairs and interruption to essential infrastructure. And the third one is limited pile length due to transport. This pile must be transported carefully with special vehicle. Their length depends on the truck's capacity, and once manufactured, they cannot be extended. If a pile is too short, it's unusable, and if too long, cutting it down wastes materials and aid costs. And the last one is heavy equipment required. Driven pile installation cannot be done manually or with simple tools. It requires large machinery like driver hammers, which may not be suitable for narrow or restricted sites. This machine also involves high rental and operation costs along with skill level.
Hello there, my name is Nur Awafika binti Zulkarnain. This case study is designed to collect and temporarily store rainwater before it is released into Sungai Maung Kanan. Not only that, to provide structural stability, such as during flood occurrences, the precast reinforced concrete piles support the ground structure beneath the flood mitigation system. Their role is important in the following ways. Number 1, deep piles are driven deep into the earth to anchor structures to sturdy subsoil or bedrock, avoiding the soft and soggy topsoil common in flood-prone locations. This establishes a solid base capable of supporting the dry pond structure during times of high water pressure. Number 2. Prevention of differential settlement. RC piles serve to transfer heavy loads into deeper ground, preventing the flood basin from settling unevenly. This decreases the likelihood of fractures appearing in retaining walls or pavement, which could result in leaking or structural failure. Thirdly, resistance to lateral and uplift forces. Flooded soils exert both lateral and upward strain on structures. RC piles resist these forces by acting as anchors, preventing the dry pond from sliding, tilting, or rising during storm surges or extended flooding. Lastly, improve soil-structure interaction. RC piles improve the link between the ground and the structure by enhancing the stiffness and stability. This lowers soil deformation during loading, allow the pond to maintain its shape and function under stress. Now we're moving on to recommendation. Based on our study's finding, the following recommendations are proposed that can be done to replace RC piles. Is located at Batu Kawa Recreational Park for Anti-Flood Park Project. Number 1, board piles, or also known as casing city piles. But why, you may ask? Board piles are suitable for urban flood control structures where low vibration is essential. A temporary casing is installed and the earth is drilled out through specialized instruments. If the hole requires additional assistance to stay open, casing or drilling fluid can be employed. Full-length reinforcing steel is lowered into the hole, then filled with concrete. Board piles can be drilled to the depth of more than 60 meters, with typically diameters up to 2.4 meters. Now, moving on to advantages, which are high load capacity, available in diameters up to 450 mm, can be installed in various soil and rock conditions, minimal settlement and deformation, lastly, low vibration. But when it comes to advantages, it always follows with disadvantages, which is greater corrosion Now we'll be talking about advantages, which are high load capacity, available in diameters up to 450 mm, can be installed in various soil and rock conditions, minimal settlements and deformation, and lastly, low vibration. But when it comes to advantages, it always follows with disadvantages, which are greater corrosion susceptibility when the diameter is small, more expensive compared to alternative foundation methods, and if it's not properly installed, it might cause damage to surrounding earth and buildings. In comparison to other piling methods, it is noticeably smaller, and loose soil can make installation rather complex. Up next is steel H piles. These piles are driven deep into the ground and can support large loads in flood-prone or soft soil situations. It can also be coated to improve corrosion resistance. H piles have the same thickness in the flange and web as they are wide as they are deep. H piles beams H configuration to allow for better weight distribution over larger area than normal beams, which enables them to sustain larger and heavier construction. Now, the advantages are this sort of steel pile is capable of both friction and pile compaction. The splicing technique is straightforward. The handling of the steel H pile is easy, can be driven into the ground with a pile driver, making installation rapid and simple. Now we're moving on to disadvantages, which are prone to corrosion, which reduces their lifespan and necessitates constant maintenance. Steel piles are often more expensive than other types of piles, prone to buckling in loose or very soft soils, and lastly, creates a strong vibration and loud noises which might disturb in a sensitive or urban setting.
In conclusion, using precast reinforced concrete piles at the Batu Kawa site was a practical and effective solution for dealing with weak soil conditions. This method ensured that the loads from the future structure can be safely supported, preventing settlement and improving overall safety and performance. Through this case study, we learned the importance of selecting the right foundation system to match site conditions, as well as how theoretical knowledge is applied on site. The experience and information gained from this study will be very useful for us in future engineering or construction projects.